Have you ever heard of a game called Name That Tune? The contestants bet that they can name a song in fewer and fewer notes, and whoever claims the fewest notes gets to try to name that tune. Place Autocomplete works a lot like that. A great autocomplete experience guesses what you're looking for in as few characters as possible. The best is when I only have to type in one letter and the place I was looking for is the top prediction. Let's imagine your Place Autocomplete search bar is a contestant in this game. Predict that place, and you want it to predict what your user is typing in 4 characters or less. Something a lot of developers don't know is that when you're adding Place Autocomplete to your app, you can give it some clues about where the user is or what kind of place they're looking for, so that the right prediction comes up in fewer characters. When developers don't provide these clues, the results can be a bit off base. For example, if I'm searching for the London Corbin Airport in Kentucky, I don't want to see a bunch of results in the UK or other cities named London around the world. If I use autocomplete without any location bias, I have to type in 8 to 10 characters to find what I want. However, if the developer has implemented correct location biasing, I only have to type in 3 characters, and there it is. I'm going to teach you how to use Place Autocomplete properties to get what the users are looking for in fewer characters. The first clue to give is the location boundary. You can use location bias and location restriction depending on how exact you want to be to improve the quality of predictions and keep them to the right geographic area. Location bias allows predictions to come from anywhere, but the predictions closer to the bias are weighted more, so they have a higher ranking and show up closer to the top. Location restriction sets strict boundaries that only offer predictions that fall within the specified zone. First, define the boundaries of your location property. The easiest way is if you're displaying a map, capture the bounds of the map's viewport and set the location bias to that viewport's bounds. You can also define a rectangular boundary by specifying the corners or the north, east, south, and west latitudes and longitudes. If you know you only want to deliver predictions inside the boundary, define it as a location restriction. In the Places library Maps JavaScript API and the Web Services Places API, use the strict bounds parameter to return only results within a specific region. In the Places SDKs for Android and iOS, it's referred to as location restriction. The second clue you can give is if your website or app is only used in a small list of countries, you can set a property called component restrictions to eliminate predictions outside that list of countries. Countries need to be passed as a 2-character ISO 3166 compatible country code. For example, VN would provide only results in Vietnam. Here's an example of specifying several countries to include in the component restriction. Side note, while you're thinking about specific countries, you might be interested in the language parameter to return results in a certain language. Searches will be biased to the specified language, and results in that language may be ranked higher. The third clue you can give to Place Autocomplete is what kind of places your users are looking for. Chances are your implementation is probably being used for either typing in an establishment name, like the Taj Mahal, or for typing in an address or a geocode, and that can help the autocomplete narrow down the possible predictions significantly. You can use place type filtering to present more relevant predictions. Pass a types parameter to specify a type or a type collection. Here's an example of what happens when a user inputs GREAT into a Place Autocomplete field with a location bias for New York. First, with no place type filtering, we see a mix of cities and establishments in New York and nearby states. If we filter for just geocodes, we see a street and a neighborhood appear alongside the city name predictions. There's also a place type filter for just cities. Now, if we apply a filter to see just establishments, we get a very different looking set of predictions. As you can see, specifying what type of place is expected on the page where you're presenting Place Autocomplete can make a big difference in what shows up. Thanks for joining me to learn more about how to make your Place Autocomplete search bars win the Predict That Place game with location and type properties. Although they're optional, they can turn a poorly performing Place Autocomplete search bar into a winner that presents the right prediction with just one character. There's a lot more I can tell you about how to improve your Place Autocomplete performance and optimize the costs when your app's usage scales. Check out my other videos about how you can master Place Autocomplete to predict that place in fewer keystrokes for your users. Comment below to tell us what you'd like to see in future geocasts. Thanks for watching and happy coding! So I was watching old episodes of Name That Tune, and I was really struck by how intense it is. Like, one contestant will say, "Jerry, I can name that tune in 5 notes." And the other one will say, "Linda, I can name that tune in 2 notes." And just using their names makes it so personal. It's like too much.